Deratech factory is a place where technological innovation meets exquisite craftsmanship. The combination of precision machining techniques and strict quality control ensures that every machine delivers outstanding performance to meet customer needs. The first stage involves steel plate cutting at the Phase 1 and Phase 2 factories. The steel plates used for the company's products are sourced from large, well-known domestic steel mills. They are cut using top-notch German Messer CNC flame cutting machines and high-precision CNC fiber laser cutting machines, which provide high efficiency, smooth and flat cut surfaces. Flame flattening is then used to apply localized heat to deform the steel plates, which after cooling results in irreversible plastic deformation. Next, the CNC spotting machine is used to pre-drill small guide holes in the press brake side plates after the steel cutting process. Before welding, a V-shaped beveling is cut into the cylinder mounting plate. To increase the welding strength, add the connection between the cylinder mounting plate and the side panel. The next step is the welding process. The cylinder mounting plate is welded to the side plate, and the lower beam are welded to the side plate using a dovetail structure, making the key load-bearing parts more solid and reliable. We use Fanuc robots for automatic welding, ensuring high efficiency and stable welding operations through precise positioning and control. After welding, ultrasonic testing equipment is used to inspect the weld seams for cracks, pores, or other defects. The annealing process follows to eliminate stress in the steel plates. The plates are heated to a specified temperature for a certain duration to relieve internal stresses. Deratech uses intelligent dual-card automated annealing furnaces with a working length of up to 8.5 meters. Next, the machine undergoes precise sandblasting. Our large sandblasting chamber can handle workpieces up to 8 meters long, using high-speed abrasive particles to impact the surface, achieving cleaning, beautification, reinforcement, and improved mechanical properties and corrosion resistance. After sandblasting, the primer is applied. The surface of press brakes is coated in 2 layers, primer and top coat. The primer, an eco-friendly water-based coating, enhances the adhesion and fullness of the top coat, ensuring optimal absorption and coating quality. The welded frame and other structural parts are left outdoors for an extended period to allow natural release of internal stresses, improving dimensional stability. Next comes the precision machining stage. We own over 50 large precision machining units, including European flatter CNC floor-type boring and milling machines, 5 top-tier Queer CNC floor-type boring and milling machines from China, and 4 high-tech gantry machining centers. These machines ensure both high accuracy and high efficiency during processing. These critical machines are used to manufacture high-precision press brake frames, slide plates, and other large structural components. They can complete all machining tasks in a single setup, ensuring the foundation of product accuracy. Once the machining is complete, dial indicators are used to check the precision, ensuring that parts meet design and quality standards, ultimately improving the pass rate. After machining, the next step is the application of the top coat. We have a large painting booths ensure high-quality coating and environmental compliance throughout the painting process. In the final stage at the Phase 1 and Phase 2 factories, the hydraulic oil tanks of the CNC press brake, made of stainless steel, are precision bent using CNC press brakes. Welding is done by robotic argon arc welding, ensuring neat welds and minimizing the risk of oil leakage. After welding, the tanks are thoroughly cleaned in the Phase 3 factory using custom ultrasonic cleaning machines before assembly. The first step is assembling the hydraulic system components, including the hydraulic valve group, servo motor, and oil pump, onto the oil tank. Once inspected and approved, the assembly is moved to the parts warehouse. The second step involves the electrical system assembly, where workers install the electrical cabinet, route the wiring, and assemble relays and other electrical components. The third step is mechanical assembly, installing linear guides onto the back gauge beam. The parallelism and straightness are checked on a granite platform, and the components are then stored in the parts warehouse. The X-axis and R-axis components are assembled using a modular design, including ball screws, linear guides, and base plates. This modular approach facilitates mass production and ensures the stability and precision of the mechanical structure. After assembly, the parts are transferred to the warehouse for storage. Upper and lower wedges are cleaned, lubricated, and then assembled along with the reducer and flanges. The mechanical compensation work table is also assembled. Finally, all pre-prepared components, including the oil tank, electrical cabinet, back gauge, slide plate, CNC system, and mechanical compensation device, are mounted onto the machine frame. The modular approach improves assembly efficiency and quality, laying the foundation for mass production. Before shipping, technicians perform comprehensive machine testing, and quality inspectors conduct a rigorous examination. Only after passing inspection is the machine packed for shipment. Precise debugging of the press brake is the critical part of the production. Skilled technicians carefully adjust the machine to ensure it is shipped in optimal condition to customers worldwide. The quality control team safeguards the company standards by ensuring that all components and machines meet stringent requirements. Every press brake undergoes a high-pressure test before leaving the factory, ensuring the CNC system, hydraulic seals, and transmission parts operate reliably. Each machine is carefully packaged before shipment to protect it from dust and moisture during transport. The company has a professional logistics team to handle both domestic and international orders, ensuring safe and compliant product transportation. Deratech uses a modern ERP management system to manage production planning and material requisition. This system enables the precise management of various internal data, ensuring a rapid response to market demands. First, steel plates needed for welded components are cut using a laser cutting machine. The cut edges are burr-free, smooth and flat, with minimal heat distortion. The high precision of the cut parts ensures easier control of the welding dimensions during subsequent assembly of the machine frame. Next comes the welding stage. The frame of the laser cutting machine adopts a mortise and tenon welded structure, which is sturdy and resistant to deformation. Carbon dioxide shielded welding is used, offering stable welds with minimal internal defects and reduced spatter. After welding, the frame is polished to remove slag and burrs produced during the welding process, resulting in a smoother surface finish. After welding, the next step is annealing, where temperature and time are precisely controlled to fully eliminate welding stress, ensuring the stability and accuracy of the frame. Following annealing, the sandblasting process is carried out. Sandblasting the surface of the weldment enhances the adhesion of the paint coating, laying the foundation for the subsequent painting process. The next step is machining. Deratech uses a process flow of rough machining, natural aging, finish machining, During rough machining, large feed rates and cutting depths are applied to remove as much material as possible in a short time. CNC gantry machining centers are used for finish machining of critical installation surfaces like the rails and racks, ensuring high-quality installation basis in maintaining cutting precision of the machine. Our company uses a primer and top coat spraying process. The primer has stronger adhesion, making it less likely to peel off and providing better sealing properties. It effectively seals the base layer and also helps create a smoother surface for the workpiece. The top coat, being the outermost layer of the coating, plays a major decorative and protective role. The company has a dedicated large component painting booth that meets the strict requirements for temperature, humidity, lighting, and air cleanliness. After painting, the assembly process begins. Technicians perform flatness and straightness checks on the installation surfaces for key precision parts like the machine's base rails and racks. The assembly is carried out according to the process flow card to ensure the quality of each machine throughout the entire process. Through the integration of various optical components and supporting software, dynamic performance testing of the machine is conducted. Parameters such as positioning accuracy, repeatability, and fine movement are measured to provide data for error correction, ensuring optimal performance. Each laser cutting machine undergoes dynamic performance testing using a laser interferometer and ball bar instrument. This measures parameters like positioning accuracy, repeatability, and fine movement, allowing timely data processing for error correction and guaranteeing product quality. Deratech's Phase 4 Factory Product Demonstration Center showcases the full range of CNC machines, including CNC press brakes, CNC shears, CNC grooving machines, CNC turret punch presses, as well as panel bender and press brake with robot and laser auto-loading systems. Here, customers can engage with professional engineers to receive detailed technical explanations and operational demonstrations. The company's robotic press brake unit integrates advanced multi-joint industrial robots with CNC press brakes for automated material handling, alignment, bending, and stacking. This setup supports customized production. PLC control enables continuous, unmanned operation, completing multiple bending and flipping processes in one go, reducing immediate steps, improving production efficiency, and helping customers achieve lean manufacturing. Deratech's laser automation unit is equipped with highly efficient ARW030158 8-layer single-row material warehouse, specially designed for the sheet metal processing industry. This system meets the high demands of automated production. With a large storage capacity and a single-layer load capacity of up to 5 tons. It significantly boosts material handling efficiency and flexibility, automatically identifying plate specifications and switching materials, reducing manual intervention, and supporting seamless automated production workflows.